we are going to, you are now, multiply and divide rational expressions. Now, as has been noted, we went from 8.1 to 8.4. The reason we did that, we are getting to the point in our book where we're going to need to make some choices as to all of what material we cover. Not, it's all good material, it's all important. But we have to choose because we don't want to be in school in July. So, 8.2 and 8.3 are about graphing rational expressions, rational functions. Guys, quit. And you will, if you go into pre-calc, we'll do an extensive section on graphing rational expressions. So I know that if you continue on with your math, that you will get this at a future point. We're going to look at just some real basic stuff with it, but we're not going to go into all the details with them at this point. So we're going to go straight to simplifying, multiplying and dividing rational expressions. So mostly we're going to be talking about dividing today, simplifying fractions that involve variables. Okay, remember rational numbers, or numbers that can be written as a fraction. So rational expressions are expressions written as fractions. So first thing we're going to do is just do a little review and remind ourselves how we simplify fractions. If I have a times c divided by b times c, how would I simplify that?
A over b.
Yeah. The c divided by c is 1, and so 1 times a over b is just a over b. So that would be simplified. How about the next one? Can I simplify it?
No.
That is correct. So for those of you who do this, I don't know, I have to come up with something special for something. Don't do that.
Distribute the bottom by a negative.
This one can't simplify at all. It is simplified as much as it can be. Now, if it helps, when you have this, put parentheses around this. And think about a plus c all as one factor. Or another way to think about it is if you look at numbers, put numbers in there. Says a is 3, 7, c is 7, 4 is b, be 3 plus 7 over 4 plus 7. Well, that'd be 10 over 11. If I crossed out the 7s, it would be 3/4. Not the same number. Okay, so if you put numbers in there, then it makes sense. So don't you do it if you have letters either. Okay. Now, how about if I have a plus c divided by a plus c?
1.
That's 1. Number divided by itself, and this is one factor, that's one factor, that's just 1. When we say everything cancels out, we mean everything except 1. Okay, so now let's look at the fraction here. 15 over 65. How would I go about simplifying that one? Divide by 5. On the top and the bottom. Now, essentially what you're doing is factoring 5 times 3 over 5 times 13, and then canceling 5s, and so you get 3 over 13. That's exactly what we're doing today. We just happen to be factoring polynomials instead of just numbers. So if you look at this one down here, 4 times x plus 3 over 8 times x minus 5 times x plus 3. What's going to cancel here?
X plus 3.
X plus 3.
And 4 and 8.
And then the 4 goes
1
into
half.
4 once, and the 4 goes into 8 twice.
1 over 2x minus 5.
Okay. So, yeah, so everything canceled on top, but don't forget to put the 1 up there. And then you have 2 times x minus 5. And you simplify. Okay? Make sense? Okay, so let's practice with some similar to what you're going to be looking at today. Okay, so I have x squared plus 7x all over x squared. What do I want to do first?
Take out an x on top.
Okay, we're going to factor. And when you factor, the first thing you always look for is the greatest common factor.
X squared.
So an x in both.
Oh, wouldn't the x squareds cancel each other? No. If they're by themselves, though. No.
It's just like what we just did. Don't do that. Because this is a plus, not a times. So this has to be considered all as one thing up here. All of that has to be there to cancel. Okay, so I'm going to factor. So an x, what's left?
X plus 7.
7 all over x squared. Okay, so I have an x in the top and x squared in the bottom.
X plus 7 over x.
Yep, so I subtract my exponents, x to the 1, so I can, 2 minus 1 is 1, so this is going to be x to the 1. I now have x plus 7 over x, so be careful. Okay, so let's look at the next one. Yes.
Why doesn't, when you minus your exponents, it would be 1 minus 2, right? So when it turns to a negative, wouldn't you take the x and bring it up?
Okay. Good question. If I say 1 minus 2, that's negative 1. So that would be x to the negative 1 times x plus 7.
Oh, okay.
Which is this.
Okay.
Okay. So, and either one of those forms would be correct. Okay, so next one. Always factor first. So let's look at factoring the top. When I'm going to factor a trinomial, I need 2 sets of parentheses. So on the top, this is an x squared. So I have an x and an x. It's a negative 15. I have a minus and a plus. Okay, what two numbers are going to work there?
3 and 5. Negative 3 and 5.
Other way.
Negative 5 plus.
Negative 5 plus,
Ready, quick.
because negative 5 plus 3 is a negative 2. Negative 5 times 3 is negative 15. Okay, what kind of a special factoring am I going to use there? X plus 3, x minus 3. Did anybody remember the word we have for that?
Binomial.
Good guess. Difference of two squares.
Never mind.
Difference of two squares. Remember that? Does that sound familiar?
No. Yeah.
X plus 3, x minus 3. Oops. Too many parentheses. Okay, these match. And so I get x minus 5 over x minus 3. That's it. Okay, so what we're saying essentially is that this one is the same as this one, which we're going to look at with your calculator in just a minute. After we do this, this will be our last one of these, and then we're going to get your calculator out and play with these.
So what about?
Okay. X squared plus 6x plus 8. Factor that one.
X plus 2.
Okay, x plus 2, x plus 4, because 2 times 4 equals 8, 2 plus 4 equals 6. Okay, how about the bottom one?
X plus 3.
X plus 3, x minus 1. Because 3 times 1 is the only factors of 3, and the 3 has to be positive. Anything common to top and bottom?
Oh, no.
No. I want you to just write them in that form.
Yeah, I was gonna say, how is that any different from that though? It's like the exact same thing.
It's-
I guess when you get littler, it's the exact same thing, but that does that, why do you have to write it like that?
It's the same because I want to see that you factored it. That's for my benefit, so I know that you're doing your work. Okay? But yes, this and this are exactly the same function, just different forms. You are correct. Okay, so let's see, that one's tomorrow.